Okay, the lab technique called calorimetry means calorie measuring. Okay, so it's a way of measuring calories. In the old days, calories was how we measured heat. But now we use the joule, and joule is the SI unit for heat. But, just as an aside, you should know that 1 calorie is 4.18 joules. So if you have to convert between calories and joules, you know how to do it. It's just a T-bar conversion. And interesting enough, food calories, 1 big C calorie, okay, those are food calories, they're big C calories, are 1,000 little c calories. So that makes it 4186 joules. So 1 food calorie is 4,000 joules. So kind of keep that in context of some of our kinetic energies and our gravitational potential energies that we've done so far. Now back to the calorimetry idea. How does it work? Calorimetry, basically what we have is some sort of insulated container, aka a styrofoam cup. Most of the time we use a styrofoam cup. When you're a big wig and you go to some big deal fancy college, they will have actual, fancy calorimeters. But most of the time we just use a styrofoam cup or some other insulated container. And basically the container is supposed to prevent heat exchange with the environment. So all of the heat exchanges are going on inside the calorimeter. So here's our calorimeter. Oftentimes it is filled with a fluid. Most of the time that fluid is water. Okay? And you place something into the water, and heat is either going to flow into the something or it's going to flow out of the something. So if this is a hot piece of metal, if this was a hot piece of metal in here, then our heat would flow out of the piece of metal. If it were an ice cube, we would have our calorimeter filled with our water and the ice cube inside, and the heat would flow into the ice cube to melt it. Now here's the big idea with calorimetry, is that the heat lost by one part equals, that's a T, the heat gained by another. So in the case of our piece of metal, the heat lost by the metal, the Q of the metal, is equal to the Q of the water. Now, generally, when you lose heat, okay, you have a negative heat. Losing is bad, so losing is negative. So since our metal lost heat, it would be negative. And then our water gained heat, so it would be positive. So the MC delta T, because the metal is going to change its temperature as it cools off until they come into thermal equilibrium. Want to guess what that word means? Thermal, heat, equilibrium, same. So these guys are the same temperature. Okay, so once they come into thermal equilibrium, they're at the same temperature. So the negative MC delta T for the metal is equal to the MC delta T for the water. Easy enough? Now, in the case of our ice cube, okay, let's think about what's going to happen here. In the case of our ice cube, the heat is flowing into the ice cube, so the heat is lost by the water. And what does it do to the ice cube? Okay, it's going to gain, the ice is going to gain heat, and so it's going to melt the ice. Heat used to melt the ice. But when the ice melts, what temperature is the water it's going to give off? That water, that melted water that came off the ice, is going to be at 0 degrees Celsius. So it needs to come and change its temperature to our equilibrium temperature. So we also have the heat to change the temperature of the ice water. So this, you need to think about what processes are going on here. So our equation in this case, it's still heat lost by one is heat gained by the other. So the water changed its temperature, so it's MC delta T, and it lost it, so that's going to be negative, is going to equal to the heat gained by the water. So when water melts, we use ml, and when it changes temperature, we're going to use the MC delta T, and this is for the ice water. So none of these equations are the equation. The equation is that the heat lost is equal to the heat gained. That is the equation. Okay, then you need to figure out, well, what's losing heat? In this case, it was the hot water. And the reason this negative is kind of a technicality, because when you find your delta T, it's T final minus T initial. Okay, and when your water loses heat, it comes into a colder temperature. So your final temperature is a little bit smaller than your initial temperature, or a lot smaller than your initial temperature, depending on how much it cooled off. And so this number is going to come out to be negative, and this negative out here makes everything positive so that all the math works out on the other side. But this is the equation, that the heat lost is equal to the heat gained. You have to remember, conservation of energy. Energy may neither be created nor destroyed, so it has to go from one place to the other. And in this case, it goes from the water, it goes from the warm water into melting the ice and then changing the temperature of the ice water. Okay? In the case of our metal, our piece of metal, it was the heat lost by the metal, because the metal was hot. The heat lost by the metal, and it changed its temperature, so you use an MC delta T, is equal to the heat gained by the water. Some things you should know. The heat capacity for water, I'm not sure if I've told you that yet, is 4186 joules per kilogram degrees Celsius. It's a little bit bigger than what you saw in chemistry, because we're talking about per kilogram, so it's a lot bigger. In chemistry, you were doing joules per gram. So this is just for water. Every material has its own heat capacity. In fact, when you go to do some of your heat calculations with ice and steam have different heat capacities than just water does. So you need to make sure you use the heat capacity for the state of matter that you're talking about. So that is like the big idea, huge big idea, being that the heat gained equals the heat lost. And that should get you conceptually through the problems. We'll see you tomorrow. Good luck.